So I guess some of you will have had a look at these lecture notes that I had online. I just want to make a couple of very, very quick comments about these things in addition to what I've already told you, which is that they're perpetually under construction. The idea is that you've got some evaluation of the level of importance of equations within that. One of the questions which is often asked is, what do I need to know by heart? What do I need to understand and what not? So this is codified inside these lecture notes, and this is what I'll be following for this course. So in the little introduction, you've got something about contextual colors. Those of you who've done web programming know all about CSS and whatnot. So these are dressed up with some snippets of CSS doing this. At the beginning of many of the sections or even exercise and whatnot, you've got some comments about prerequisites and maybe objective stuff that you're meant to learn or cover in these things. More importantly, if an equation is inside a box which has this kind of slightly dark shade of green, it is core material. And my definition for this is that I just want you to be completely comfortable with this. And if for you that means knowing it by heart, then that's what it means. Okay? If it just means that you really understand how to use it, then of course you know it by heart, stuff like that. So things like, in the Coulomb's law, at some point, Maxwell's equations, so that I can already tell you at the end of this course, you will have to know Maxwell's equations. Yeah, you call it by heart, but I call it by understanding. So these equations, not the majority of them, a minority of them are really things that you have to begin with. Okay, so these are also the beginning points for you in your study. There are some other equations that are labeled as like main matter. And these are equations that you really know how to use. So if you're in a situation where you've got a problem and maybe the equation is accessible in a book, you really know how to use it. So maybe examples. If you are asked to solve, we'll see later, Laplace equation and whatnot, and you need the expression for the Laplacian in spherical coordinates. Okay, it's got all these nasty sine theta and 1 over r dr, blah, blah, blah. This one, I don't really want you to know it by heart. However, if it's given to you in a table, I want you to be able to confidently use it. Therefore, the Laplacian in spherical coordinates is a main material equation rather than a core. Okay, just a little subtlety. I'll try to be relatively systematic on this. In the notes also, you've got some examples. The idea of the examples in the notes is that they are the minimal applications of the stuff that has just been exposed. So these things here are really the types of things that if you have, the core equations in your head, the main equations on your notes on the side, you should really be able to do on a blank sheet of paper. That's a very good test. The problems are very well posed. We'll do a few of them today. But these, for you to gauge your understanding, you should be able to reproduce these examples from a blank sheet of paper with the notes accessible. Okay, and the rest is just fun tidbits about either history or well, not politics but conventions and whatnot. You'll see some examples of that today. Okay, so I hope that's all relatively clear. Now, the sections in the notes also, I use a kind of localization scheme, which you will either find utterly irritating and never come to terms with it, or maybe at some point come to see some advantages of it. Every single section, subsection, sub-subsection comes not with a number, but with little letters, coded letters. And this is great because the little coded letters, I don't need to change if something gets added in between. So for example, today we are going to do electromagnetostatics, core part. And we're going to do electrostatics. Therefore, on the site, this is EMS, electromagnetostatics. Yeah, and then electrostatics, EMS.ES. Okay, so if sometimes I write EMS.ES, it's because it refers to that particular section. And it's also on Canvas with the lectures that you have. You'll be able to recognize just by hovering over the link which one it is. There are permalinks to these things. Sometimes, in a set of notes or in an exercise or something, we just give a link to this, and then you can come straight to the right section in the notes. The equations also carry this kind of more semantic a description. So first of all, in the table of contents, you've got it kind of organized. So we've already talked about electric charge. I'm actually not going to go about this here. Anyway, there's no meaningful content on the lecture notes at this stage. This is what we've discussed last time. Today we're actually going to talk. We're going to begin with electric force and energy. Okay, and we're going to begin with Coulomb's law. So that's a good beginning. I'm just showing you the notes, what essentially I'm talking about today. And I'm actually not going to be using this. Okay, so this is where you are in the online notes for what we are doing in class. Okay, so today that's what we do. We are going to work on Coulomb's law, and then you'll have to get used to my writing. I have to get used to my writing. Coulomb's law. Okay, and this is in section EMS.ES, electrostatics. Okay, just so you know where we're going.